Hello, this is Scott Hill. We're going to talk about units. In the course, ME 34395, spacecraft propulsion, we're going to use two sets of units. One is the imperial system, which is mostly used in the United States, and the other is the SI system, which is used in the rest of the world. More and more, we're moving towards the SI system, so you have to be proficient in both of them. So the question is, what are the units? For the SI system, the units of mass is kilograms. The units of time is seconds. The unit of length is meter. When you go to the English system, or the engineering system, whichever you want to call it, units of mass is a slug. So the question is, what the hell is a slug? The units of time are the same. Seconds. And the unit of length is feet. So all the other units that are used in the systems are derived units from these situations. The question becomes, what is the relationship between the two? So the question we talk about typically is force. One of the units of force in the SI system, the units of force is a Newton. And in the English system, it's a pound force. Well, how are they defined? What is the relationship? And we go back to Newton's F equals ma. So for 1 pound force is equal to 1 slug. Acceleration is 1 foot per second squared. And that's the definition. 1 pound force is the force that will make this much mass move at 1 foot per second squared. Same thing is true for Newton. 1 Newton is equal to 1 kilogram times 1 meter per second squared. We know what a kilogram is. It's a quantity of mass. We know what a slug is. It's a quantity of mass. Are they the same? No. Are they related? Yes, because physics is physics and they must be the same. So the units for Newton become kilogram meter second squared. That's what the units of a Newton are. The units for a pound force is slug feet per second squared. On the surface of the Earth, the force of gravity means that this must be true also. F equals ma. The force of gravity on the surface of the Earth is 9.806 meters per second squared. And in the English units, this is 32.174 feet per second squared. One of the things that, if you study this a while, if you look at it a while, you'll find that a slug is a very large unit. In fact, a slug is the amount of mass that will weigh 32.174 pounds on the surface of the Earth. And you can get that by pound force rather, is equal to a slug times 32.174. So this quantity of mass, a slug, weighs 32.174 pounds on the surface of the Earth. So then the next question that people have come up to is they want to use a smaller unit. So they have a pound mass. And a pound mass is simply a slug divided by G sub C is equal to a slug divided by 32.174. And this means that a pound mass exerts 1 pound force on the surface of the Earth. This is a key point. So the next question, or a logical question anyway, is how much force does a kilogram put on this have at the surface of the Earth? And the answer is kilogram of mass weighs, i.e. exerts a force on the Earth, let's see if I can look it up here. Hang on a second. 2.2046 pounds force at Earth surface. In other words, a kilogram weighs 2.2046 pounds at the center of the Earth, on the surface of the Earth. Notice that it's absolutely incorrect to say that a force of kilograms. Kilograms are units of mass, and the unit of force is a Newton. What is the relationship between a Newton and a kilogram is G sub C, this relationship. So if you take force equals MA, you will find a Newton is equal to a kilogram times 9.806 meters per second squared. And that is the definition of a Newton as kilogram meters per second squared. So the force in newtons is equal to kilograms times G sub C. Newtons.